And it's time for the space weather. We're looking at the SDO imagery here in multiple wavelengths, and there's a calibration maneuver going on there, which is less than optimal for viewing the data, but the SDO needs to make sure that it is fixated on the center of the solar disk. If you're wondering what kind of orbit the SDO flies, there's some imagery of that. It flies this figure 8 pattern over the equator from around the New Mexico desert down to the South Pacific Ocean in order to maintain a constant view of the closest star. Here's a colorized magnetogram, and we continue to see a dip in solar activity here over the past several days. We've also got another spectacular coronal mass ejection to cover and lots more, including some Earth weather information, meteorology, dare I say the word climate, at the Smash News Network least busted name in news. We'll get to it. We see extremely calm seismic conditions here, so not even an earthquake in the 5 magnitude range over the past 24 hours. Is it the calm before the earthquake storm? Leave us a comment and let us know what you think. So here's the situation. Again, no quakes over a 5 magnitude. So we're not even going to cite any individual quakes, just the fact that it's been very, very calm in terms of earthquakes for the past 24 hours. Remember, folks, earthquake droughts end in large earthquakes, and any earthquake can be a foreshock. Volcano rundown coming next. Shiveluch continues to explode on the Kamchatka Peninsula and produce a flight level 170 over the Russian territory. 17,000-foot ash plume from Shiveluch. 15,000-foot ash plume over Guatemala from Fuego as Fuego explodes. Flight level 150. Flight level 230 over Nevado del Ruiz in Colombia. It's exploding as well and producing a 23,000-foot ash plume. Sangay, similarly in Ecuador, producing a 22,000-foot ash plume as it explodes. And last but not least, Sabancaya, 24,000-foot ash plume from Sabancaya. And remember, folks, please don't pole vault the caldera. It could be unhealthful. Let's get back to the realm of space. Here's some spectacular 131 angstrom imagery. And there was a long-duration C-class right in the center of the Earth-facing solar disk right here toward the end of the video after this calibration move. And there is a coronal mass ejection, yet another one. Also forecasts for some geomagnetic storm and unrest conditions in the coming days. We'll get to it. Here's ionized helium, 304 angstroms. And again, wait till the end, you'll see this. There's the long duration C-class flare there happening right in this area. Let's let it play through one more time here. And we'll get to that coronal mass ejection toward the end of the video. The radio flux has come down to 133 solar flux units. There's the 1-year chart of that. That's going to come down to about this point right here. And there's a space weather enthusiast dashboard. You can see NOAA here forecasting geomagnetic storm conditions late tonight, early tomorrow, late tomorrow, and early on July 23rd. So those are from both coronal mass ejections and high-speed coronal hole wind streams according to NOAA. We'll just leave that there and move on. Let's look at the last 4 hours of Earth's magnetic moment from space. And by the way, this magnetic information right here, this is why solar protons don't make it all the way down and strike you directly on the planet. Earth has a magnetosphere, and those protons get caught up in Earth's magnetic fields. That's our Geospace Magnetosphere movie. We show it daily on the channel. And it's partially because we're unable to access this data in an archival format. So we at least show 4 hours each day here on the channel. We'll also show Earth's magnetic moment from the ground. And we are seeing geomagnetically calm conditions at the moment. This is ground magnetic perturbations, geospace delta B, changes to Earth's B field. And if you see really dark red areas, those are the most likely places to see things like aurora and induction into power lines, railways, and pipelines. Again, things pretty calm here at the moment. We've got a KP of 2 is the current geomagnetic measurement. That's a global geomagnetic measurement for your new viewers. And hey, thanks for tuning in. Let's look at the real-time solar wind here. We're seeing a ramp up in the solar wind density. So we may see a little early onset here of a coronal hole high-speed stream. We did not see the second coronal mass ejection show up. Maybe that one missed entirely. Chances are it has. But the current conditions are about 15 protons per cubic centimeter for the solar wind density. Solar wind speed, 375 kilometers per second. Keep in mind that's measured at Lagrange point 1, about 1 million miles away from Earth. Approximately 4 lunar distances toward the Sun, in between Earth and Sun, at the gravitational equilibrium point known as Lagrangian point 1. Here are your GOES magnetometers over the past 3 days. Keep in mind these N's and M's mean noon and midnight local time for the satellite. That gives you some insight into where the locations of them are. For example, we're just past midnight for the GOES 17, indicating it's on the opposite side of the Sun right now as it makes its magnetometer measurements. Next, we'll look at the heliospheric current sheet. The plasma coming from the Sun is oriented to one pole or the other. Earth is in a south pole oriented current sheet, as you can see there in red. Nothing new going on as far as that goes. Keep in mind the magnetic environment can change suddenly. Here's our line of sight field plot. You can also see the solar magnetogram there. We've got some Earth-facing coronal holes here of south pole orientation. So quite a lot of coronal holes there. And some very well-defined ones here in the Earth-facing zone. The Sun's B field shown here in blue. So here's 193 angstroms. You can see those very well-defined coronal holes. We're expecting some significant geomagnetic unrest or geomagnetic storm conditions in about 2 to 3 days from those well-defined coronal holes. And there are additional coronal holes over here in the east, which are not very well-defined because of bumpy plasma obscuring them. You can see a little bit of definition showing up down here. They're all south pole-oriented coronal holes. And let's move to sunspots. Sunspots have been mostly stable here over the past 24 hours. Nothing too exciting going on as far as that goes. There still is some significant possibility of solar flares. And these groups have degraded a little bit since yesterday's video. Here's the 1700 angstroms wavelength. And that's what's going on in terms of sunspots. A little bit of reduction here in solar activity overall. Low the past 24 hours. So we did have this long duration C-class solar flare that happened right around midnight. Peak flux was actually a little bit later there, around 1:10 universal time, and that's a very long duration flare there, lasting well over an hour. And it was a C5.65 class solar flare. "94 angstroms is a great wavelength to view solar flares. It takes 10 images per minute instead of only 2. And again, it came out of this sunspot region right here. And let's move on. Plenty more space weather and Earth weather to cover. That solar flare did not produce any relativistic particles that made it to Earth. There's the GOES proton flux corroborating what I've just stated. Now, this video was originally streamed live to Twitch, thanks to our new Twitch followers. We love using the live streaming platform here at Smash News Network, least busted name in news. Maybe download the mobile app for that. and more on what we're up to here in a moment. First, a star chart we encourage our viewers to look up. I went on a pre-dawn bike ride this morning, and there were some great views of Venus in the pre-dawn hours. Venus, the third brightest object in the sky, my personal favorite planet. Let us know what yours is in the comments. Let's show a solar system forecast. We've recently moved into a crescent waning moon as we approach another new moon. Let's do a 1-week forecast. And there's where things will be in a week. New moon on or around the 28th of July coming, as is Mercury, as it has swung around the opposite side of the sun. Now let's take a look at some of these coronal mass ejections. So this is yesterday, and you'll see right at the end of the video a little bit of activity happening there. Let's switch to today. There's today, and starting out the day with some CME activity. Is it earthly directed? Well, we don't think so. It looks like it's off to the northeast. And we'll show some additional views here from this time only Lagrange point 1, stereo A's coronagraph imagery not yet available when we did show prep. So here, as we paused here at 1:48 Universal Time on the Soho-Lascaux C2 on the left, and at 3:42 on the Soho-Lascaux C3 here on the right. And you can see we don't really see a halo associated with that. In other words, no ejecta on this side, all the ejecta headed off in this direction. That is the northeast. So that's what's going on in terms of the latest coronal mass ejection. Still some ejecta there coming out at the end of the video. Again, not likely to be earthly directed. No earthly components likely in that CME. Continuing on to our hydrogen alpha imagery, this is great at showing solar filaments. You can see those dark regions, those are absorption features that are blocking the hydrogen alpha imagery. The most hydrogen is located in those lighter regions, around sunspots especially. And they show up as absorption features, filaments, when they're in between the Earth and Sun. They're similar to these prominences that you see down here. And there are still significant number of filaments in the earthly portion of the solar disk. Don't be surprised to see additional coronal mass ejections. Remember, folks, our regular viewers are aware coronal mass ejections don't require sunspots or solar flares. Here's the latest couple of hours from the NASA GOES 16 SUVI. We've got some more SDO imagery. Here's some composite imagery. This is 211 angstroms and 171. Two different species of ionized iron there. You can see some plasma reorientation happening as this coronal hole appears to be closing right before your very eyes. Here's the zoomed out version of that. You see that coronal hole there closing at the end of the video. Today's featured product is do not pole vault the caldera. Folks, don't pole vault the caldera. It's a public service message brought to you at massive personal risk and expense by Smash staff and I here at smashomash.com. If you're going through hell, keep going. Our finest days lie ahead. So don't take your track and field team on a field trip to a caldera to practice your pole vaulting over a volcanic crater, especially an active one. That could be unhealthful, and we need the views on YouTube. So thanks to everybody who's tuned in, and this is our second best seller, by the way. You can get all kinds of different products here, from floor pillows to shower curtains. We've got the socks, and they are quite comfy. So don't pole vault the caldera. Do press like, subscribe, share, etc. And if you want some tangible items, visit the link below the video or on our homepage. We've organized that link in order of best selling. So we can't decide what sells best. That's up to you, the consumer. And please, don't pole vault the caldera. Do visit our links. Thanks to our new subscribers over on YouTube. Congratulations on realizing the channel exists. And by the way, if you'd like to support the channel via subscription services, we created our own subscription services starting October was our kickoff, October of 2021 for the Smash Team website. Smashomash.com/SmashTeam. Support us via a gold or silver membership to continue to increase the probability these videos will continue to exist and remain publicly visible. We put up a post there, publicly visible for the CME spotted. And just for our gold level subscribers, we've put up a post yesterday about facts on inflation. If you want to read about that, you got to be a gold member at smashomash.com/SmashTeam. You can find links on the homepage and below this video. Our homepage is smashomash.com, where we welcome you to the Neo-Renaissance. And we assure you we're writing a kind of important paper explaining the solar sunspot cycles. We're pretty sure we've uncovered the mechanism that underlies it through a process of induction and deduction. In science, often we end up with answers to questions not asked, which is what's happened. And when that happens, we go with it. Once again, welcome to the Neo-Renaissance. Thanks to everybody who has supported the content over the last 5+ years. Here come the bonus features segment. Starting with the total electron content. This is showing the free electrons between your GPS satellite and your handset. So out to about 12.5 thousand miles of altitude, these are where the free electrons are likely located. And your GPS signal can be refracted by thousands of miles, producing huge GPS errors. They usually happen around the equator at noon. Things calm down here as far as anomalies in the total electron content forecast. There's a diagram of distances to certain objects like Van Allen probes, the International Space Station, which orbits at about 230 miles of altitude. And again, your GPS satellite's located at about 12,500 miles of altitude. Here's your satellite's community dashboard, and things are pretty calm. As far as satellites go, no charging hazards at the moment. Next, here goes electron flux. There's the last 3 days as measured through radiography by your GOES 16 and GOES 17 geosynchronous near equatorial satellites. There's the NOAA forecast model for relativistic electrons. And when we get coronal hole wind streams, we can indeed expect to see quite low figures for the GOES electron flux. There's the 1-year chart to put it all in context. We're just at moderate levels here of relativistic electrons. We'll also show the Ionosphere layer as we do daily. It's located at about 300 kilometers of altitude. And we'll show the vibrational frequency and the anomalogram. So here's the ionogram showing vibrational frequency in megahertz, or millions of vibrations per second. And here's the anomalogram showing anomaly in megahertz from the 30-day median. So this is in many ways to be considered the bridge between Earth and space. It's a very diffuse portion of the atmosphere. And it's full of ions because it's largely not shielded from solar radiation, which blasts electrons off of neutral molecules, making them into ions instead. In any case, there's the latest image. That's 10 o'clock Universal Time ionogram. And there's 10 o'clock Universal Time anomalogram. Next, let's bring up the latest high-res image, the solar intensitygram from the SDO and the magnetogram. There's the intensitygram, and we still do have quite a few named sunspot groups here. Some of them are fairly complex. This one close to the equator is a beta-gamma class sunspot group. That's beta class, that's beta class, and that's beta class. And these are the most likely regions to see additional solar flares at the moment. Those are magnetically complex sunspot groups, as you can see here from the magnetogram. They've got opposite polarity umbrae. And let's bring up one more composite view. This is Iron Star. 3 different species of ionized iron here from SDO. So just give that a minute to load. That is yesterday and today in 335, 193, and 94 angstroms. Continuing on to our meteorology segment, and thanks for staying tuned. And we're going to start things out here looking at sea surface temperature anomalies and ocean currents. So we like to cover the Gulf Stream at least once a week here, and the Gulf Stream has a tendency to bring warm water up to places like Ireland and Iceland. So that is typically the way that current flows. And at the moment, it is being obstructed a little bit by some cold, anomalously cold water there in the North Atlantic. So you can see some hot and cold water anomalies happening here. But there still is some current flow all the way up here in the North Atlantic. And Europe certainly not freezing at the moment. I somehow don't suspect Europe is seeing a year without a summer. I would also note how cold Lake Superior is. Check out Lake Superior. We've got anomalously cold Great Lake. And Lake Michigan has actually cooled down. Just a few days ago, Lake Michigan was anomalously hot. Now it's got some anomalously cold temperatures in it as well. But Lake Superior, very cold there at the moment. And let's switch to the normal view that we typically show daily on the channel. It's the 250 hectopascal winds, otherwise known as the jet stream. So there's the eastern world. Shout out to our viewers from under and from over the equator. Some backward jet stream continuing here over the northern Indian Ocean and West Pacific. Here are the surface winds of this side of the planet, like sands through the hourglass of time. These are the surface winds of your lives. Here are the surface winds of the Americas. And here are the jet streams of this side of the planet. We still continue to see an upper-level anticyclone here in the southwestern U.S. There you go. Once again, we've got this high-pressure zone, this clockwise rotation happening over the southwest. You can see it there on the jet stream imagery. It's a heat dome in many ways. Here are the jet streams of Europe, Africa, and the Middle East. And you can see that backward jet stream there continuing across the Indian Ocean and over North Africa, even continuing a bit into the North Atlantic there. And a bit of jet stream chaos here, blowing some cold air down into Eastern Europe. Here are the surface winds of this side of the planet. And let's move on. Here's your weather.gov map. We've got some red flag warnings there happening in... Oh, those are excessive heat warnings there in the southwest. Also some heat advisories in the south-central U.S. and up the entire East Coast. Expecting temperatures of up to 100 degrees in parts of eastern Pennsylvania. If you're wondering where we're located, right here in Lehigh Valley is where Smash Staff and I are located. Here's your NASA GOES lightning mapper and some very concentrated lightning there over places like Kentucky and West Virginia. Moving into Tennessee and western North and South Carolina as we make the video. Here's a real-time lightning map from lightningmaps.org. And let's see what we've got. We've got some terrestrial lightning indeed over central Tennessee at the moment. Some quite active cells there. Here's where your most recent lightning strikes are occurring. Convince the natives that you're Thor or Odin by forecasting thunderclaps using the spectacular lightningmaps.org, powered by blitzortung.org. And next we've got your 72-hour GFS pressure and precipitation forecast for the lower 48. Expecting some very strong storms coming to South Carolina there in about 3 days. And we show the 72-hour GFS forecast because it tends to be accurate. We don't idiotically show a 10-day forecast on the channel. Those are from Tropical Tidbits, by the way. That's what the homepage looks like. Just click on Forecast Models if you want to create your own. Here's our temperature anomaly forecast based on the same GFS model for the next 72 hours. Keep in mind degrees are displayed here in Celsius. So some wild swings of temperature once again showing up here on the temperature anomaly forecast. And again, that's based on the GFS model and shown in degrees Celsius. Some huge swings happening there, some low and high temperature anomalies occurring across the U.S. While we're talking about temperature, let's check and see if Greenland has melted yet. I know there are a lot of concerns about Greenland melting, so let's just check some snow depth here. Let's go to the southern tip, just the tip. More than 5 meters down there. So there's like 17 feet of snow. How about in the central portion? More than 5 meters there. Now here's a part of Greenland that CNN should probably cover today. 0 inches of snow there. It's time to panic. And let's go south of there. And oh my God, there's only 175.9 inches of snow in that portion of Greenland. Better sound the alarm bells. And do all kinds of other ineffective things. Because, hey, oh my God, Greenland is melting. I'm very scared. Are you scared and spooked? Let us know in the comments how frightened you are of the prospect that Greenland could melt. I mean, think about the implications, folks. If Trump buys Greenland and all the snow melts, how is he going to start a water company based on Greenland snow? I mean, Greenland ice sheets, Trump water, I think it's a match made in heaven. Anyway, here's your U.S. Doppler radar map showing all 50 states. Some precipitation there in southern Alaska, central Alaska, and even in western Alaska. We'll focus on the lower 48 for the remainder of the video here to close out our meteorology segment. We can see those strong storms there headed southeast, having just left the Nashville area as skies clear. Next, your shortwave radiation satellite, 3.9 nanometers, is the wavelength. That shows clouds and fog, and here's water vapor. That should help to clarify things. We're getting an impulse from some dry, massive air right here. This is a relative high pressure zone. And it's sandwiching that moisture in between some more dry, massive air, causing huge pressure gradients and that violent weather. So here is your recap, the U.S. Doppler radar. That's vertical motion of water droplets in the air column. Here is shortwave radiation in the infrared spectrum showing clouds and fog. And that is water vapor. That's what you want to go to if your Doppler is not giving you the answers. We hope you're able to forecast your own weather. Thanks for tuning in as we show what's going on in both Earth and space here at the Smash News Network, least busted name in news. And may that solar wind be at your back.